Good afternoon, everyone, and welcome to our live coverage of the latest mission from NASA's Kennedy Space Center. I'm Will Robinson-Smith, reporter with Spaceflight Now, so good to be with you this afternoon. We're broadcasting, as we always do, from the Spaceflight Now News Bureau here at KSC. Well, despite the weather prediction coming into this launch opportunity, things look pretty darn nice as SpaceX and its customer EUMETSAT are counting down to the planned liftoff of this Falcon 9 rocket that you see standing tall at Historic Launch Complex 39A. Meteorologists had forecast just a 20% chance for favorable weather at liftoff, with concerns including violations of the cumulus cloud, anvil cloud, and surface electric fields rule. But taking a look at the wide shot out here, you can see some of those cumulus clouds that are hanging around the Space Coast, but honestly, pretty far offshore and don't look too threatening as far as liftoff of the Falcon 9 rocket. We've certainly seen much worse in recent days and even months. SpaceX is currently aiming for liftoff of its Falcon 9 rocket at 5:04 p.m. Eastern, 21:04 UTC for those joining around the world. We'll have much more to say about the payload on board and the flight of this Falcon 9 as we get things rolling here. Currently T-minus 1 hour, 26 minutes, 47 seconds, and counting. First off, though, I want to thank the little more than 600 of you who are watching with us live as we get going today. If you haven't already, you could do us a big favor just by clicking the like button and sharing the stream. Allows more folks to find their way into this live launch coverage. Also want to thank our moderators, Jeff Hansen, Rick Donner, for being with us today, helping us out in the chat. Just scrolling to see if there are any other mods hanging out in the background. Not seeing any at the moment, but if you do see any of the other mods with a little wrench icon next to their name, be sure to give them a big old Spaceflight Now hello. You can help make their jobs that much easier just by following the rules of the live chat. We ask that you refrain from delving into overt politics and religion in the chat, that you don't use all caps when you type your message, that you converse in English so that our mods can respond as appropriate, and last but certainly not least, that you treat each other with the kindness and respect that you yourself would like to be treated with. We're also powered by a wonderful channel member community here on YouTube. Make these live launch opportunities possible. So thanks to folks like The Rocket Girl, Butterfly, Aiden C, I Am Lita, Joni, Sulfur for Lunch, and many others. Channel membership comes with a number of perks, including discounts at our online shop, which is shop.spaceflightnow.com. Access to member-only videos here on YouTube, access to our members-only Discord server, and of course the ability to watch all of our live launch liftoff moments from here in Florida in 4K. Speaking of our member community, I want to thank Rick Donner for gifting 5 Spaceflight Now memberships, growing our channel member community here just that much more. And so to our 5 newest channel members, welcome aboard. We're glad to have you with us. And if you haven't already, be sure to thank Rick in the live chat. We hope you decide to stick around with channel membership beyond the month you were just gifted. As we're going through the countdown today, if you'd like an overview of this mission beyond what we're talking about in any given moment, we've got a good write-up on the satellite and its instrumentation. That's on our website right now, the top story at spaceflightnow.com. Also, if you have a comment or question about this mission or other goings-on in the realm of space or spaceflight, you can use the YouTube Super Chat feature. And not only will it be giving us some interesting things to talk about as we cruise on through the count, but you'll also be supporting what we do here at Spaceflight Now. And that, my friends, is always greatly appreciated. Running the technical operations of our broadcast this afternoon is our Spaceflight Now editor, Stephen Young. We've got our John Pisani, who's out getting ready to track the Falcon 9 rocket, do a little still photography as well, believe. Our other photographers, Michael and Adam, are off at the moment, so nevertheless, if you are not following the fellows on X, you can find them at their handles here on the screen. John is at John Pisani Photo. Michael is at MD Kane Jr. Adam is at Apeburn NYC. And if you're not following Spaceflight Now, be sure to follow us simply at Spaceflight Now. You can find us on X, Threads, Blue Sky, and Facebook. Time now, T-minus 1 hour, 18 minutes, 53 seconds and counting. As we're getting ready for the start of fueling the Falcon 9 rocket, let's go ahead and take a moment and walk you through the countdown timeline. let you know the milestones that SpaceX needs to get through before it's ready to launch its Falcon 9 rocket. Of course, things will begin at the T-minus 38-minute mark. That's when SpaceX launch director will give the call on the start of prop load. Once that go-ahead is given, fueling of the rocket will begin at T-minus 35 minutes with the loading of RP-1, a rocket-grade kerosene on board the Falcon 9's first and second stages. At the same time, liquid oxygen will begin flowing on board the vehicle's first stage. 30 minutes out, cryogenic helium will start to be loaded on board the vehicle's first stage. Same will be true on the second stage a few minutes thereafter. Helium is important because it's used to pressurize the main propellant tanks during flight. T-minus 23 minutes, second stage RP-1 loading wraps up. Then at T-minus 20 minutes and 50 seconds is when the strong back chill down process gets underway. SpaceX at this point in the count will be thermally conditioning the feed lines there at the pad ahead of second stage liquid oxygen load. We see this visually manifest as the so-called big vent. Here at pad 39A, we should see this begin at about T-minus 20 minutes and 30 seconds. The venting lasts about 4 minutes in duration here at this pad, wrapping up and then stepping into second stage LOX load around the 16-minute mark. T-minus 7 minutes is when the engine chill, the Falcon 9 booster, begins. SpaceX will flow a small amount of liquid oxygen through the plumbing and turbo pumps, helping to protect the engines from the risk of thermal shock and damage during startup. 6 minutes out, the first stage kerosene tank is full. Then at T-minus 4.5 minutes, we'll see the strong back retract sequence get underway. It starts with the clamp arms just beneath the payload fairings opening up, and then the transporter erector, otherwise referred to as the strong back, will recline a few degrees away from the Falcon 9 rocket, stay in that position until liftoff, at which point it'll pull back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9. 3 minutes out, the first stage LOX tank is full. Same is true on the second stage, about a minute afterwards, at which point the Falcon 9 rocket is fully loaded with 1 million pounds of propellant. In the final 60 seconds, as we hear the call that the Falcon 9 is in startup, control of the countdown is handed over from the ground sequencer to the Falcon 9's onboard flight computers, and the propellant tanks are brought up to flight pressure. SpaceX launch director will give their go for launch 45 seconds ahead of flight. The engine ignition command is issued at T-minus 3 seconds, and if all 9 Merlin engines are healthy and ignite as expected, the command will be given for the hold-down clamps to release the Falcon 9 rocket for a T0 liftoff. Once again, targeting currently 5:04 p.m. Eastern, 21:04 UTC, T-minus 1 hour, 15 minutes, and 35 seconds. Taking a look at our chat here, want to thank channel member Butterfly, who's been a member with us now for 18
Meteosat
months.
Third Generation.
Apologies for that little preview of a video we've got cooking for you in the background. Butterfly says in their 18-month tweet or post, thank you all for watching launches with me for a year and a half. One day I hope to meet some of you. Yeah, we've been talking about some potential ways to have some FaceTime with you all that we're still percolating in the background, so nothing to announce right at this moment, but I'd certainly love to get some thoughts and feedback, and especially from our channel members. The mission that is launching today is referred to as the MTG-S1 EUMETSAT-S1, that is the Meteosat Third Generation Sounder #1. This is part of the next generation of weather monitoring satellites that's being launched primarily on behalf of EUMETSAT. However, this particular satellite, this sounder, also carries a payload from the European Commission, which is the Sentinel-4 payload. This is the first time that a singular spacecraft, is being launched in partnership between EUMETSAT and the European Commission, so a key partnership milestone. This satellite is one of 3 that will operate in concert in geostationary Earth orbit in order to provide some robust information for the European continent. We had the opportunity to speak with the MTG program manager about the sounder satellite and some of its facets, and we'll get to that in due course over the course of this broadcast here. We'll want to start first with an overview, broadly speaking, of the MTG program, and these animated versions of the satellites will help give you an understanding of how they work in concert.
The Meteosat Third Generation system consists of 3 satellites. EUMETSAT maintains these satellites so they have a continuous view of the Earth. The first of the satellites hosts the prime service, which is the imaging service. The instruments involved are the flexible combined imager, the lightning imager, and the data collection and search and rescue support platform. The flexible combined imager takes images of the Earth every 10 minutes in 16 different spectral channels. This gives us information of the clouds, their properties, as well as information on the land and water surfaces. The lightning imager consists of 4 different cameras, giving us information about lightning for the full disk, day and night. The MTG Imager service is used to provide support to nowcasting, forecasting immediate meteorological dangers. The second of the satellites in the MTG system provides the sounding services, taking vertical information of the atmosphere. There are 2 instruments, the infrared sounder and the ultraviolet visible and near infrared sounder. The infrared sounder, IRS, provides information on the temperature and humidity in the atmosphere. We get information for the full Earth disk, but we get information for Europe every 30 minutes. The Copernicus mission provides information about the composition of the atmosphere over Europe. This atmospheric composition information will be new information for weather services and other services around Europe. The third satellite in the constellation provides the rapid scanning service. It also hosts a backup of the lightning imager. Here we get images of Europe every 2.5 minutes. This is important for monitoring very rapidly evolving storms. All of the information for the MTG system is made available across Europe and the world and is used for weather forecasting through to atmospheric composition monitoring.
Time now T-minus 1 hour, 8 minutes, 43 seconds and counting. I want to go now to part of the conversation we had with James Champion, who is ESA's program manager for the MTG program. Had the chance to sit down with him yesterday ahead of the planned launch today. In this part of the conversation, we really drilled into the benefits of having the sounder instrument that is launching on board this MTG-S1 satellite and having that in a geostationary Earth orbit, this being the first sounder that is launching to geo from Europe, or on behalf of ESA, the European Commission, and EUMETSAT. So here's part of our conversation with James Champion.
So with the sounder, we're looking at an instrument that's looking through the atmosphere. It's doing vertical profiling. We've managed to separate the Earth, split the Earth up into 4 quarters, and we'll scan one of these quarters every 15 minutes. The way we operate is scan the bottom one first, and then we do Europe, and then the next one up, and then we do Europe again. So we get a repeat cycle over Europe every half an hour. But even within that, there are many, I can't remember, about 100, 200 plus scans and dwells that it will do. And it's taking all of that data through the vertical profiling down to Earth and then being processed. We're not just thinking about data in one frequency or 2 frequencies. So you and I, we can see the 3 primary colors, and that's how we work. In the olden days, we had monochrome TVs with just one color. No, here we've got 1,700 different frequencies that are being scanned at a time, which is a huge amount of difference. And this is going to bring up an awful lot of data that then needs to be processed in order to make it usable for the users, and then sent out for the various applications that will come from this.
And our thanks again to James Champion for the conversation. Taking a quick peek at some of the other pieces of this mission, besides the satellite itself, but some of the iconography. First up, this is the pair of mission patches that go along with the MTG program. On the left, MTG-I standing for the MTG Imager, of which there will be 2 as part of this first family, as James termed it, that'll be launching over the course of today, as well as in 2026 is when the second Imager will head into orbit. The first Imager was launched back in 2022 on board an Ariane 5 rocket down in French Guiana. It's unclear whether the second and final Imager that's part of this first trio will launch on a Falcon 9, or if it will be on an Ariane 6 or a different launch vehicle. James said that was still being determined at this point in time. Given, though, that this mission is launching on board a Falcon 9 rocket today, here's a look at the SpaceX design for the MTG-S1 mission. Bouncing ahead a little bit, you can see the satellite itself as it was being encapsulated inside the payload fairings a number of days ago before it was brought out to Launch Complex 39A, where it was integrated onto the Falcon 9 rocket and rolled out, brought upright, as you see there in the live box on the right-hand side of your screen. A little bit hard to get a sense of the scale when you're looking up at the satellite inside the payload fairing, so here's an artist rendering of what we're seeing now live on the right-hand side of your screen. But if you could take a giant blade and cut through and pull back 1/2 of the payload fairings, you would see something that looks like this. once deployed from the Falcon 9's second stage, it'll take about 17 to 19 days for the satellite to head on out to its permanent parking spot out in geostationary orbit. It'll actually take quite a while to do the commissioning as well. Want to go to another part of our conversation with James in which we talk about the reason why the commissioning period will take so long, since once it's out in its orbital position, it will take another 9 to 12 months to get everything calibrated and be in a position where it's able to send back usable data. So here once again is the MTG program manager from ESA, James Champion, to talk about the reason for the long commissioning time, and it might not be exactly what you're thinking.
The majority of that time is actually spent doing the on-ground data processing. So the instrument quality tuning, for example, these take time. We've done as much of the calibration and the performance testing on ground. We know what it can do here, but when we're up there, there'll still be a lot of fine-tuning to do and to prove how good this is. This instrument has a huge amount of data coming down, massive amounts of data. So in comparison to the MTG-S1 that we launched a couple of years ago, we've got even more data coming down from that. So, and it just takes an awful lot of processing power to run through this. Once it's been tuned and all the on-ground algorithms have been proven, etc., it'll be a lot faster. It'll be up and running. The majority of that bulk of that work is done by EUMETSAT, who are our cooperating partner within this wonderful meteorological fleet of spacecraft, and they will be taking care of then distributing the scientific data to the user community throughout Europe. So the various Met offices around that are in the countries that have been helping us get to this point in time.
Neglected to mention at the top of the broadcast that we are joined with tracking assistance by our friends Chuck and Jen Briggs, whose camera view you're watching right now, as well as Pete Karstens with Max Q Productions, who will be joining us a little bit later on in the broadcast. Right now, though, we are T-minus 1 hour and counting away from the planned liftoff of this Falcon 9 rocket, and the first Meteosat Third Generation Sounding Satellite, which also carries on board the Copernicus Sentinel-4 instrument, which comes from the European Commission. If you're just now joining us, I'm Will Robinson-Smith, reporter with Spaceflight Now, and you're watching Spaceflight Now's live coverage of this mission to send this singular satellite on its way to a geosynchronous transfer orbit, where it will make a journey of a little more than half a month out to its final parking spot in geostationary orbit. Time now currently T-minus 57 minutes, 47 seconds and counting. Just a little less than 20 minutes to go before the planned point when the SpaceX launch director will make the call on the start of propellant load today. For those who were not with us at the beginning of the broadcast, weather conditions looking considerably better than what the forecast had suggested. Meteorologists with the 45th Weather Squadron showed a 80% chance of probability for violating weather constraints yesterday. Put another way, that would be just 20% chance for favorable weather. But looking outside right now, you'd be hard-pressed to call that more than 20% chance of violating weather. It looks maybe a bit breezy, but honestly not too shabby. Throwing the disclaimer that I am not a trained meteorologist, but with the primary concerns having been for violations regarding cumulus clouds and anvil clouds, I don't believe we're really seeing much of that anywhere near the spaceport at this moment in time. Of course, we'll continue to track that as we go on through the countdown, and the important sign will be once SpaceX actually starts tanking its Falcon 9 rocket there at the pad. That'll let us know that they are committing to liftoff of the rocket as expected. They do have a 150-minute window that opens up at 5:04 p.m. Eastern, 21:04 UTC for those joining around the world. With about 55.5 minutes to go, I want to thank the 1,000 of you who are watching with us live this afternoon. Hope you're all having a good start to the work week, and we certainly appreciate you joining us here for our live coverage today. If you haven't already, you could do us a big favor just by clicking that like button and sharing the stream. Allow some more folks to find their way into this live launch coverage. Also want to thank Willow's mom, aka Zeus's mommy, for upgrading their membership to the Mission Specialist level. Really appreciate that added support, Willow's mom. And a thanks to another channel member, Charles Boyer of Talk of Titusville, who says, you can hear the ospreys outside your office from time to time. Really cool. Yeah, we are continuously working here at Spaceflight Now to try and augment these live launch broadcasts and improve our hardware as well as the flow of the shows. So trying to enhance the sound as best we can for these broadcasts, and glad you're able to notice that, Charles. Thank you. And for those of you who would like more than one launch in a given day to make it a full good start to the month, we've got not just this launch coming up here in 53 minutes and 57 seconds, but at about 1:29 a.m. tomorrow morning, another Falcon 9 flight from here on the Space Coast is getting ready to take off. That is the Starlink 10-25 mission, set to fly from Pad 40 over Cape Canaveral Space Force Station. That mission is notable for a couple of reasons. Number one, that will be the 500th Falcon 9 launch to date. Number two, it will also be a record-setting launch for the booster flying that mission. That is B-1067, further cementing its place as the flight leader for SpaceX, getting ready to make its 29th flight so far, the most out of any booster by at least a few missions. And again, that launch is set to take off from Pad 40 at the Cape at 1:29 a.m. Eastern, 05:29 UTC. So we hope that some of you are able to stay up late with us or set your alarms and get up early when that rocket is ready to fly. And we'll be holding our normal live coverage beginning about an hour prior to liftoff. Back here at Pad 39A, while this particular Falcon 9 booster is not going to be setting any records as far as the leaders of the SpaceX booster pack, launch today would set a new turnaround record for this particular booster. You're looking at B1085 in the SpaceX fleet. A launch today would represent a turnaround time of 24 days, beating its previous turnaround record by 4 days. Its fastest before now was 29 days between the launches of the GPS 3-7, otherwise referred to as the Rapid Response Trailblazer mission. Between that in December of 2024 and the launch of Firefly Aerospace's Blue Ghost Mission 1, along with iSpace's Hakuto R Mission 2, coming in the middle of January. Speaking of that booster history, let's go ahead and talk for a minute, run through the other flights that this booster has got under its belt before it is ready to take off once again in just a little more than 51 minutes from now. It first flew launching the Starlink 10-5 mission on August 20th of 2024. That was followed up by the Crew 9 flight on board the Dragon Freedom, which made its fourth trip to the International Space Station, supporting that 2-member crew. Originally, this booster was supposed to fly for the first time on the Crew 9 mission. However, when this booster was transported from Texas out here to Florida, there was a little bit of moisture intrusion on the booster, and so as part of the process of making sure that they had made all the necessary fixes before putting humans in the hands of this booster, they decided, both NASA as well as SpaceX, to fly a Starlink mission first and then allow it to fly Crew 9. This mission was followed up by the Starlink 6-77 mission on November 7th of 2024, followed up by the aforementioned GPS-3 space vehicle number 7, RRT-1 as it was known up until and past the point of liftoff. Followed up by the previous booster turnaround record for this particular first stage, the Blue Ghost 1 and Hakuto R2 mission. That was followed up by another crew launch, this time Fram-2. This booster making a little bit of history for SpaceX as the first time that first stage, making its 6th flight, flew a crew. Before then, boosters flying as many as 5 times were the cap that NASA had been comfortable with, and so far that is still the case. A NASA mission supporting the Commercial Crew Program still has not flown on a booster with more than 5 flights to its name. That'll be the case when we see the next crewed mission head up to the orbiting outpost. That's Crew 11, looking for a launch either late this month or early August. That'll fly on B1094. That booster making its 3rd flight when it does head out. Flight number 7 was Starlink 6-93. That was on May 7th of this year. And most recently, the Sirius XM SXM number 10 satellite. Also another geosynchronous transfer orbit mission for this particular booster. And in just about 48.5 minutes, we'll see it take to the skies one more time in support of the MTG-S1 satellite. Taking a look at our live chat now, want to thank channel member Jeff Hansen for a $10 super chat. Appreciate that, Jeff. Jeff says, go Kennedy, go SpaceX, go Falcon 9, go EUMETSAT, Godspeed 1085, the tail number of the booster flying today. Also want to thank Angela Vanderberg, who is joining us with channel membership at the pad leader level. Welcome aboard, Angela. We're glad to have you with us. Time now, T-minus 43 minutes, 46 seconds and counting. As we're coming up to the point where the SpaceX launch director will make the call on the start of propellant load today, I want to talk about where this Falcon 9 is going to be flying once it leaves the pad. Let's talk a little trajectories, shall we? Once the rocket leaves the pad at Launch Complex 39A, the vehicle will fly heading out to a geosynchronous transfer orbit, meaning it's going to be heading essentially in an easterly flight path, heading off from Florida's Space Coast. The first stage booster, B-1085, is going to be targeting a touchdown, though, following stage separation on the drone ship called Just Read the Instructions. If successful, this will be the 127th good landing for that particular drone ship and the 471st booster landing to date for SpaceX. The company is working to certify both its first stage boosters as well as its payload fairings for up to 40 missions apiece. Following the deployment of the payload fairings, a little more than 3 minutes into flight, they will come back through the atmosphere and then make their final splashdown in the waters of the Atlantic Ocean under the support of steerable parachutes. Once down in the water, they'll be scooped aboard one of SpaceX's recovery vessels, brought back through Port Canaveral, turned over to the Hangar X site here at KSC, and then prepared for future missions. Time now T-minus 40 minutes, 35 seconds and counting. A couple minutes away from the go-ahead being given on the start of prop load today. Let's go ahead and get some more insight about the MTG-S1 satellite from our conversation with James Champion. In this part of the conversation, we talk more about some of the specs regarding the satellite, some of the ins and outs of this platform that's designed to operate in a geostationary Earth orbit for just about a decade once it is deployed and checked out. So here is the specs part of our conversation with the MTG project manager for ESA, James Champion.
Okay, so first signal of the satellite should come within a few minutes. This is the plan. This is and I'm sure it will happen. Very occasionally, the signal can be received before then, but so this could happen. But anyway, no, we're expecting it very soon after separation. You asked about a few statistics about the satellite. So its wet mass on launch is going to be about 3.8 tons. So this is I don't know, a medium weight geostationary satellite or so. The dry mass is just over 1,700. So you can work out how much propellant there is for yourself. But and then the instrument itself on top, it's a very top-heavy satellite, so we've had to compensate a lot for that in its design. That instrument's about 400 kilos. The Sentinel-4 instrument next to it is about 200 kilos. So it's a very, very top-heavy satellite that's taken actually quite a lot of design and development work into the attitude, orbit, and control subsystem for such a top-heavy satellite. So.
Just past T-minus 38 minutes now. At this point, the SpaceX launch director should have made the call for the start of prop load on this Falcon 9 rocket. We did see a little bit of venting, which tends to be a good indication here at Pad 39A that they are in preparation for the start of fueling. Time now T-minus 34 minutes, 22 seconds and counting. At this point, assuming the go-ahead was given by SpaceX, teams should be in the process of loading the Falcon 9 rocket there at the pad. This will start with RP-1, a rocket-grade kerosene on board the first and second stages. At the same time, liquid oxygen should now be flowing as well on board the Falcon 9's first stage. We're watching for signs of fueling, which of course will be that frost line that forms with the loading of super cold densified liquid oxygen on board the vehicle's first stage. If you look just in the part of the rocket, well, start with the transporter erector, you see where the strong back there starts to taper inward. Just a little bit above that, bring your eyes to the left where the booster is, and you can see a shift in color gradient from more of a dark gray to a light charcoal gray, where the Falcon booster has flown back through its plume. It's created a little bit of soot buildup. Right where that partition is where we start to see a frost line form and a little bit of vapor as well, as the difference between the super cold densified liquid oxygen and the warm humid Florida air creates that vapor effect. Once fueling has begun, we usually start to see some evidence of that somewhere between 3 to 5 minutes after fueling has gotten underway. It's a bit bright today, but this part of the booster is in shadow, so hopefully we should be able to discern when fueling has actually begun. Took just a second longer because of the lighting conditions, but we are starting to see that vapor form in the part of the booster that I was just mentioning, which means SpaceX is now fueling its Falcon 9 rocket in anticipation of a planned liftoff at the opening of this 150-minute-long window. Because SpaceX uses what's known as a load-and-go style of tanking its Falcon 9 rockets, that means it is loading propellant and oxidizer pretty much right up to the point at which it's preparing to lift off. And so once the fueling process has begun, there is no opportunity to hold the count. So this sign that SpaceX feels good enough to enter into the fueling process is good confidence that conditions will be fair for a launch. Coming up here in just a little more than 30 minutes. With less than 27.5 minutes to go, if you're just now joining us, you're watching live launch coverage of the MTG-S1 satellite mission on behalf of EUMETSAT, with a payload from the European Commission called Sentinel-4 set to lift off from Historic Launch Complex 39A out to a geosynchronous transfer orbit. Do have confirmation from SpaceX of what we were reporting just a moment or so ago, that propellant load is in fact underway in anticipation of this satellite launch. Currently T-minus 26 minutes, 48 seconds and counting. At this point, SpaceX is loading a cryogenic helium on board the pressure vessels of the vehicle's second stage. Did so regarding the first stage about 3.5 minutes or so ago. And that helium will be used to pressurize the main propellant tanks during flight. Time now, T-minus 23 minutes, 5 seconds and counting. We're coming up on the start of the big vent here at the pad, which should be getting underway around T-minus 20 minutes and 50 seconds. Once that thermal conditioning of the feed lines has begun at around T-minus 20 minutes and 30 seconds is when the big vent will begin. It's a good visual indication that, as we now have confirmation additionally from SpaceX, that fueling is moving along on track as expected. So far, this has been a fairly smooth countdown for SpaceX. Nothing notable that has caused any shift in the T0, which is always a welcome sight to see. T-minus 21 minutes and counting. The strong back chill down sequence is just about to get underway. The big vent should be starting here in about 10 seconds. And there you see the start of the big vent. This part of the feed line chill down process will last until just about T-minus 16 minutes and 30 seconds. That'll then taper off, setting up for second stage liquid oxygen load to begin. Time now T-minus 17 minutes, 21 seconds and counting. Got a little less than a minute remaining on the big event today. Not only a good indication that fueling is moving along on time and as expected, also kind of a nice wind gauge, let you know which way the wind is blowing at the pad and with how much gusto. And as the big vent tapers off, again, SpaceX is now preparing to start second stage liquid oxygen load, coming up at the 16-minute mark. As we mentioned earlier on in the broadcast, the launch of this MTG-S1 satellite comes, of course, on a Falcon 9 rocket, but it also comes following the launch of the first imager out of two that will be part of this trio of satellites working together to provide some important weather and climate data for the European continent and its customers. For those who haven't had a chance to read our preview story about this, originally when these contracts were signed to develop the spacecraft for this mission, and a deal worth about $1.8 billion. The goal was to have the MTG Imager #1 satellite launch in 2017 and this satellite launch in 2019. That Imager didn't fly until 2022, and of course this Sounder satellite is just getting ready to launch in a little more than 15 minutes. So I want to go to one final soundbite from our conversation with James Champion, the MTG program manager for ESA, to talk about the slide to the right for these satellites and look ahead at the final one that's going to be launching right now, currently set for 2026.
The shift to the right is derived from several competing factors. So this was new technology. We kicked off in 2010. Even in 2012, we were still on the cusp of developing the new technology. The detectors, the coolers, these very complicated bits of hardware, all the onboard digital processing electronics. It takes a long time, and whilst huge amounts of effort were put into trying to maintain that development schedule, unfortunately, things happen, unforeseen things happen. We mitigate every risk on the way, but you can't foresee every risk. And it's the unforeseen things that have come into play here as to why we are a little bit later than previously planned. Other things outside of our control as well was the situation with the European launcher situation. So we were very fortunate to launch MTG-I1 on an Ariane 5 towards the end of 2022. It was the most spectacular launch. It was beautiful, and the spacecraft's up there providing excellent and amazing data. We've been ready with MTG-S1 for a while, and we've been waiting for a launcher to come along, and now finally we've got one. So we're hoping to get up there and to have MTG-S1 join its sister up there and start beaming down the new products.
And as far as the timeline for being able to beam down those products, as he was just saying, the timing for deployment following its separation from the Falcon 9's second stage comes about 35 minutes after liftoff. It'll take a couple to a few minutes, maybe a smidge longer, to acquire signal as planned, and then it'll take about 17 to 19 days for this satellite to cruise on out to its planned final orbit in geostationary Earth orbit. And then following that, about 9 to 12 months of commissioning and work to make sure all the data processing computers and supporting hardware here on the ground are in position to be able to process all the data that's going to be brought down from this particular satellite. According to James, this will send about 50 times as much weather data as the second generation satellites were capable of. So you need quite a bit more robust ground infrastructure to really bring this all together. Time now T-minus 10 minutes, 34 seconds and counting. Here's another peek at the satellite that's preparing to launch, and a look at the pad level view of the Falcon 9 rocket provided by SpaceX. Want to give a little bit of a note here. You can see our countdown clock in the upper right hand corner of the screen, a little bit ahead of what's coming in through the SpaceX feed. Reason being, our clock is in real time. What's coming down from SpaceX is on a slight delay. So as long as we've got tracking level views with our own cameras, we'll be making callouts based off of real-time events until we're solely reliant on the SpaceX onboard cameras. As a reminder, as far as what we'll be seeing today, the deployment of this satellite is going to be happening about 35 minutes and some change following the liftoff of this Falcon 9 rocket. And given this is not a classified customer, we are expecting to see live deployment views of this particular satellite. So we will be with you throughout the course of liftoff through the coast phase and onto the deployment of this important sounder satellite. Now just a little less than 8.5 minutes to go before the planned liftoff of the Falcon 9 rocket and the MTG-S1 satellite. So far, a nominal countdown, nothing to write home about, which is exactly what you want to see ahead of a rocket launch. For those of you who were not with us earlier in the broadcast and taking a quick peek at the live chat, I see we've got a little more than 3,600 of you watching with us live, so a few more than we had back at the beginning about an hour and a half ago. So want to re-rack a piece of tape from our conversation with James Champion, who is the MTG program manager for ESA, to talk about the Sounder satellite and its benefit, as this will be the first time that EUMETSAT and ESA are deploying a Sounder satellite into geostationary Earth orbit. Here's that part of our conversation with James Champion.
So with the sounder, we're looking at an instrument that's looking through the atmosphere. It's doing vertical profiling. We've managed to separate the Earth, split the Earth up into 4 quarters, and we'll scan one of these quarters every 15 minutes. The way we operate is scan the bottom one first, and then we do Europe, and then the next one up, and then we do Europe again. So we get a repeat cycle over Europe every half an hour. But even within that, there are many, I can't remember, about 100, 200 plus scans and dwells that it will do. And it's taking all of that data through the vertical profiling down to Earth and then being processed. We're not just thinking about data in one frequency or 2 frequencies. So you and I, we can see the 3 primary colours, and that's how we work. In the olden days, we had monochrome TVs with just one colour. No, here we've got 1,700 different frequencies that are being scanned at a time, which is a huge amount of difference. And this is going to bring up an awful lot of data that then needs to be processed in order to make it usable for the users and then sent out for the various applications that will come from this.
Time now, T-minus 5 minutes, 36 seconds and counting. Coming up here in just about a minute is when SpaceX will begin to pressurize ahead of the retraction of the strongback. And we have confirmation that strongback retract tanks are pressurizing. In a moment, we'll be seeing those clamp arms just beneath the payload fairings opening up. And then that large structure just behind the rocket from this vantage point will recline a few degrees away from the vehicle. SpaceX doesn't often talk about its payload fairings and the number of flights that it's performed, but those look like pretty new fairing halves, if not completely new. Coming up on 3 minutes ahead of liftoff. Also have our Michael Caine, who's out on the press lawn getting ready to shoot this Falcon 9 rocket as it makes its ascent. Less than 3 minutes now. First stage liquid oxygen loading should be complete. Nice view of Launch Complex 39A, where you can see quite a bit of construction is going on. SpaceX will confirmation of stage 1 LOX load. Eventually, SpaceX will be adding a landing pad to LC-39A as it will lose its lease on landing zones 1 and 4. And so it will need landing zones here at their pads, both at Launch Complex 39A as well as Pad 40. T-minus 2 minutes and counting. Rocket shall be fully loaded with 1 million pounds of propellant.
Coming up shortly, we should hear that.
Stage 2 locked load complete.
And
Right now you're seeing the ground gas closeouts. This is SpaceX removing the remaining liquid oxygen from the feed lines there at the pad. Approaching the final minute before liftoff. Should be hearing a call a little bit past the minute mark for the Falcon 9 being in startup. Again, the SpaceX clock is moving a little bit behind ours since it's coming in on a slight delay, so we'll hear that call out in about 10-ish seconds from now.
Falcon 9 is in startup.
And with that, we're just awaiting the SpaceX launch director to give their go for launch, and the Falcon 9 will be cleared to fly. 30 seconds.
Launch director, go for launch.
And with that, we've got a green light for this Falcon 9 to take off coming up in just about 20 seconds. 15 seconds. And here we go. In 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition and a liftoff. Liftoff of the Falcon 9 rocket and the MTG-S1 satellite for EUMETSAT. The Falcon 9 has cleared the towers. And a minute into this flight, a nominal flight of this Falcon 9 rocket so far as it cruises past some clouds. Rocket is now throttling down as it passes through max Q, the point of greatest aerodynamic pressure on the vehicle. Throttling back up. Coming up in just about a minute will be the start of a few events in fairly rapid succession. We'll see first stage main engine cutoff, or MECO, at about T plus 2 minutes and 28 seconds. That'll be followed by stage separation and then the ignition of the Merlin vacuum engine on the rocket's second stage. Fairing separation is expected about 3.5 minutes into flight today. Got confirmation of MVAC chill as we're 2 minutes into this flight. Less than 30 seconds to MECO. About 5 seconds to MECO. MECO. Stage separation. And should have second stage engine start. There we go.
Just waiting
And
on
MECO.
that. There's that MECO call out they were looking for.
Stage separation confirmed. MVAC ignition.
We're now coming up to fairing separation. Seeing a little bit of the plume in the bottom right-hand corner of your screen off the engine nozzle. Might be a tad bright to see fairing separation, although it looks like Chuck may have a good view of it in his tracker. Yeah, you can see those extra dots that are around the second stage. Those are the payload fairings. And a really nice view of the MTG-S1 satellite with those fairings falling back to Earth. The fairing recovery vessel that SpaceX is using today is going to be Doug, named after former NASA astronaut Doug Hurley, one half of the duo that flew the Demo 2 mission back in May of 2020. Coming up, the next milestone is the entry burn, which will begin at about T plus 6 minutes and 11 seconds, lasting less than 30 seconds in total. SpaceX will use 3 of the engines on the vehicle's booster to begin to dramatically slow that part of the vehicle down. Looks like the booster has reached its apogee today, topping out at about 120 kilometers in altitude. And we heard confirmation that both the first and second stages continue to follow a nominal trajectory. So good news for this flight so far. All going exactly as planned at this point in the flight. A little more than 5 minutes into the mission now. Taking a look up through the inner stage there on the left-hand side of your screen. Sun right down the barrel of that part of the rocket, so that's why it looks like half of it is not visible, just being obscured by that sun glare. Six minutes into flight now. More than likely it's too bright to see the entry burn with our tracking camera, so we'll be relying on the onboard cameras from SpaceX in order to see that event. Again, that's coming up at about T plus 6 minutes and 11 seconds, so just a couple seconds from now.
Stage 1, entry burn startup.
One FTS is saved.
Good calls for both the entry burn and the flight termination system being safed. That was the reference to the FTS you just heard a moment ago. Again, this burn lasts less than 30 seconds. And with the conclusion of that entry burn, we're now awaiting the start of the landing burn, which should come just a hair before minute 8. And right about at the same time as when second stage engine cutoff will also occur on this mission. We're now just about 10 seconds away from the start of both the entry burn, or the landing burn, as well as second stage engine cutoff. Let's listen in.
Stage 1 landing burn.
And good call out there for the landing burn start on our Falcon 9 first stage.
Nominal orbit insertion.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And there's that call out of landing confirmation for our Falcon 9 first stage. As a reminder, this was the 9th launch and landing for this first stage, which previously launched NASA Crew 9, RRT-1, Firefly, Blue Ghost Mission 1, From 2, Sirius XM-10, and 3 Starlink missions. We also heard a call out for nominal orbital insertion.
With that, Stage 2 is embarking on its coast phase, after which the MVAC engine will relight for a second time at about T plus 26 minutes. This will be followed by another short coast and then payload deploy.
We're going to take a quick break now and
As you just heard from the SpaceX commentators, the upper stage of the Falcon 9 now entering into this coast phase. It will have a second burn on the upper stage engine that you see right there, coming up at about T plus 26 minutes and 54 seconds. That'll burn for a little more than a minute, putting the upper stage on the right trajectory for a deployment of the MTG-S1 satellite into a geosynchronous transfer orbit, coming up at T plus 35 minutes and 11 seconds. In the interim, we're getting some launch replays ready for you, but want to take a moment now and thank a few folks for your support as we continue our ongoing live coverage of the MTG-S1 mission, launching on behalf of ESA and EUMETSAT. Thanks to Michael McRory, one of our channel members, alongside fellow channel member Stephen Frazier, for each gifting a Spaceflight Now membership. Really appreciate that from the both of you. To our new gifted channel members, welcome aboard. We're glad to have you with us. If you haven't already, be sure to thank Michael and Stephen in the live chat, and we hope you decide to stick around with channel membership beyond the month you were just gifted. Time now T plus 14 minutes, 7 seconds and counting. At this point, we're just about 12-ish minutes away from when the next event is coming up on this mission, the reignition of the Merlin vacuum engine on the rocket's second stage for a burn lasting just a little more than a minute in duration. I want to thank channel member moderator Rick Donner for gifting 5 Spaceflight Now memberships. Appreciate that, Rick. And to our 5 newest gifted channel members, welcome aboard to all of you. We're glad to have you with us. Be sure to thank Rick in the live chat if you haven't already, and we hope you decide to stick around with the channel membership beyond the month that you were just gifted. As we're getting near the end of our coverage here and with the deployment of this satellite, I want to talk about the next steps for this vehicle once it does separate from the Falcon 9 rocket, as our live views of the vehicle will end shortly thereafter, and I don't think that SpaceX is going to be sticking around through the acquisition of signal, but that point should come just a few minutes after satellite separation from the upper stage. At that point, there will be a roughly 17-day transfer period for the satellite to go to its operating orbital position out in geostationary Earth orbit. This particular satellite will require a roughly 9 to 12 month commissioning period before it is able to fully join the MTG-I1 or Imager-1 satellite that was launched back in late 2022. For those who were not here when we discussed this part of the mission earlier in our broadcast, I want to go to part of our conversation with James Champion, the MTG program manager for ESA, who talked about the reason why it takes so long to commission this particular satellite.
The majority of that time is actually spent doing the on-ground data processing. So the instrument quality tuning, for example, these take time. We've done as much of the calibration and the performance testing on ground. We know what it can do here, but when we're up there, there'll still be a lot of fine-tuning to do and to prove how good this is. This instrument has a huge amount of data coming down, massive amounts of data. So in comparison to the MTG-I1 that we launched a couple of years ago, we've got even more data coming down from that. So, and it just takes an awful lot of processing power to run through this. Once it's been tuned and all the on-ground algorithms have been proven, etc., it'll be a lot faster. It'll be up and running. The majority of that bulk of that work is done by EUMETSAT, who are our cooperating partner within this wonderful meteorological fleet of spacecraft, and they will be taking care of then distributing the scientific data to the user community throughout Europe. So the various Met offices around that are in the countries that have been helping us get to this point in time.
And again, our thanks to James for the conversation talking about the satellite and the mission and the work it's going to take in order to get it to be part of the fold. James has been a part of the MTG mission now going on 15 years, so one of the members of this operation who's been with the program the longest and is certainly looking forward to a good deployment here coming up now in less than 20 minutes. As we're awaiting the launch replays to show you, carry over to the deployment of this satellite or leading up to the next burn, want to show you some of the photography that was captured of the moment of liftoff. This coming from our photographer Michael Kane, who was out here at the press site. Nice moment of liftoff as the Falcon 9 rocket took off initially from Historic Launch Complex 39A here at NASA's Kennedy Space Center. Unfortunately, you never know exactly how the wind is going to play into your plans, but here's a nice photo of the Falcon 9 as it passes behind the American flag just a couple of days ahead of the 4th of July here. nice symbol of cooperation between an American launch provider sending up a critical weather monitoring payload on behalf of their European customer. As we mentioned a little bit earlier in our coverage, the first of the 3 MTG satellites, that was the first imager that was launched on an Ariane 5 rocket in late 2022. And following this launch here, the final of the trio is set to take flight in 2026, although we don't know just yet whether it's planned to fly on another Falcon 9 rocket or if it will launch on board the Ariane 6. Now 20 minutes into this flight, we're coming up on that next milestone, and just a little less than 7 minutes from now, the reignition of that Merlin vacuum engine on the Falcon 9's second stage. Want to thank channel member Chuck Close for a very generous $25 super chat. Appreciate that, Chuck. Thank you so much for your support at that level today. And we've got those launch replays ready for you. We're going to start and stop a little bit. We're going to begin with first with John Pisani's vantage point here at the press site with his wide camera view. Moving on to the clock view here. You can see our photographer, Michael Kane, in the bottom left-hand corner of your screen, making a cameo down there. Getting that flag shot that we just showed you. You can see the man at work. Moving on to Pete Carson's south tracking view. Now currently T plus 23 minutes, 38 seconds and counting into the mission. A little bit of a struggle to track from further south of the pad here today, as you can see the rocket passing in between some slightly thicker clouds from that vantage point. coming up to is wide. We're going to come back to our launch replays in just a couple of minutes, but first want to bring things back here to the mission currently still in motion, as the upper stage has less than a minute to go before that Merlin vacuum engine reignites for a burn lasting just a little bit longer than a minute. Coming up on this burn, let's go ahead and listen in.
MVAC ignition.
And good call out there for MVAC ignition. So as I mentioned, this burn will last a little more than a minute before the second stage engine shuts down. Now, our customer for tonight's mission is EUMETSAT. The Meteosat Third Generation Sounder, or MTG-S1, will be the first ever European sounding satellite in geostationary orbit. MTG-S1 is the second satellite of the MTG system, and the imaging satellite Meteosat 12 is already in orbit.
MTG-S1 actually carries two missions, the infrared sounder and the Copernicus Sentinel-4 ultraviolet visible near-infrared light imaging spectrometer. The Copernicus Sentinel-4 mission is an ultraviolet, visible, and near-infrared sounder. It's expected to send hourly data over Europe on aerosols, which are fine particles in the atmosphere, as well as on the concentrations of nitrogen dioxide, or NO2.
MVAC shutdown.
MVAC shutdown, great call out there. As I was saying, nitrogen dioxide, or NO2.
Nominal orbit insertion.
Nominal orbit insertion, there's that call out there. We've got ozone, or O3, and sulfur dioxide, which is SO2.
At this point, with the second burn of that upper stage engine now done and dusted, we're awaiting the deployment of the MTG-S1 satellite, which is coming up at about T plus 35 minutes and 11 seconds. Good view of that satellite from the upper stage camera. We're going to hop back over to our launch replays here in just a second as we await for this final coast phase to be complete. And we'll resume with a view from the super wide camera perspective of John Pisani. Moving on to Chuck and Jen's camera view. Quick boat cameo there, having nothing to do with the launch. Moving on to John's tracker here at the press site. Coming back to the full screen tracking view of the Falcon 9's upper stage as SpaceX is getting ready to deploy the MTG-S1 satellite. Call out coming in the next about 20 seconds. Let's listen in.
Now we should be hearing that call out for payload deployment in just about 12 seconds from now.
MTG-S1 payload deploy confirmed.
Super exciting call out to hear there. You can see the successful deployment of the MTG-S1 geostationary weather satellite.
And with successful payload deployment, that'll wrap up tonight's live coverage of the MTG-S1 mission. All of us here at SpaceX want to thank our customer, EUMETSAT. We also want to thank the Eastern Range and Federal Aviation Administration for supporting today's mission. Now, if you're interested in more launch coverage, be sure to check spacex.com/launches for the most up-to-date information. And of course, remember to follow @SpaceX on X. Thanks for tuning in, and we'll see you again soon.
With the successful deployment of the MTG-1 satellite, want to go ahead and listen to some words from the director of EUMETSAT, who's speaking right now.
Face to going to someone. Think about all of those things that's led to this point. It's absolutely astounding. And it's all been supported by collaboration and cooperation across industry and public sector agencies, EUMETSAT, ESA. It's a truly astounding thing. But for EUMETSAT, this isn't the end of the story. This is a new chapter. EUMETSAT staff will work overnight and in the coming days to ensure the satellite reaches a safe orbit. And then the next chapter of this satellite will be where it serves society, provides data and information that will genuinely protect lives, protect property, and have a major impact. And for all of the teams that have been involved with this, thank you very much. But take the time to step back and realize what you've achieved and what you've contributed to. Welcome to the fleet, MTG-S1. Thank you very much.
Thank you, Phil. Thank you for your kind words. Phil, over to you, Simonetta.
Thank you. Great moment. We saw how important this mission is, how much dedication, how much work is behind the scenes of this today's symbolic, apical event. I think hundreds of people in industry, lots of people in EUMETSAT, in ESA, a collaboration between free organization, EUMETSAT, the Commission, ESA, many member states supporting it, and the value of this mission, what we will get in terms of nowcasting, in terms of air quality monitoring, is fabulous. So I was at the beginning of the decision of this mission. I must say it's fabulous to be here today also at the moment of the launch, and I would like here to thank all the people involved, everybody who has contributed, all the project teams, of course, on the EUMETSAT side, on ESA side, but particularly also OHB teams, Thales teams, everybody who has really supported the development of this project. I'm looking for the next steps.
And a huge thank you for your support. Can I ask you to lend your microphone to our gentleman here, to Abdullah Al-Mandous, you are president of the WMO. And don't fight. There are enough microphones. Over to you.
Well, thank you very much. This is my first...
And please hold the mic up so we want to hear what you're saying.
This is my first time to be...
right up against your chin.
Yeah.
Great.
This is my first time to attend the launch of a satellite. It looks like a movie for me, but it is real. This is real. So congratulations for the successful launch of the MTG-S1. I congratulate everybody. I thank everybody, all the team from EUMETSAT, ESA, for their hard work and the dedication of their time on that. I think I'm very excited that the data that we are going to receive, it will be very beneficial for the World Weather Watch and the observation, integrated global observation systems. It will be also helpful, very helpful for early warning for all. Also for the AI and machine learning, will be tremendous in a big data for that. So again, I would like to thank ESA and EUMETSAT for their sustainable support to us and very helpful for our community. Thank you very much. Thank you.
And thank you for being with us.
Very much.
And Owen, over to you.
Thanks very much. And I suppose I represent the EUMETSAT members. So certainly on behalf of EUMETSAT members, I'm privileged to be in the position here to express sincere gratitude to Phil, EUMETSAT, ESA, the European Commission, and all the partners who have brought about this wonderfully successful launch from Cape Canaveral this evening. I think really we've witnessed the birth of a common good. And as has already been said here, this common good will contribute to the protection of life and property and the promotion of societal well-being. And it doesn't just stop there. This mission will contribute to the existing remarkable capability that exists right across this planet to sense the state of the atmosphere and take the pulse of the planet every minute, every hour, every day, every week, right across the planet, driving the remarkable predictive capability that humanity now has. And this will drive the warning systems that the president of the WMO was talking about to protect life and property. And in particular, will contribute not only to European safety, but also the safety of those in least developed countries and small island development countries who need this information and who need effective warning systems now more than ever. And as we face into the future and face the challenges of growing extreme weather and the growth and the intensity of extreme weather, this system will have a massive positive impact on society. Today is a very proud day for science and for society, and as Phil says, for collaboration. Right across Europe, right across the European community, EUMETSAT, EUMETNET, ECMWF, ESA, the European Commission. This type of collaboration is enormous. Our community comes together to acquire scale and to develop the scientific capability and the technical capability to bring about these amazing, strategic, highly significant achievements for society. And as we face the challenges of extreme weather, we all know that the challenges that are facing us all are truly great. But so is the necessity. And I have to say that inspirational achievements like this, I think they serve to give us faith in the future. So for everyone who has contributed to this and to today, thank you and congratulations.
And with all those words of congratulations, let's go ahead and wind down our live coverage with a look at the mission stats as they currently stand, with a good liftoff, landing of the first stage booster, as well as a successful deployment of the MTG-S1 satellite. This was the 9th flight of the Falcon 9 first stage booster, tail number 1085 in the SpaceX fleet. This was the company's 499th Falcon 9 launch to date, the 82nd of the year so far. This was SpaceX's 437th Falcon booster reflight, or the launch of a booster that has flown at least once. This was also the 149th orbital launch within the last 365 days, the 114th flight for SpaceX from Pad 39A, and the 208th orbital launch from this pad as well. Here's the bar chart representation of the launches on the year so far as compared to years prior. Moving on to some recovery stats. A good touchdown to the booster marked the 127th landing on the drone ship called Just Read the Instructions. That marked SpaceX's 381st drone ship landing and the 471st booster landing for SpaceX. Finally, with some industry stats, this was the 57th orbital flight from Florida, the 87th from U.S. soil, the 97th from a U.S. rocket company, and the 145th orbital launch around the world. There have been 3 orbital launch failures so far, and here's where our pie chart now currently stands. Want to close things out with a few more photos from our photographers today. These next 3 coming from our Michael Caine. As the Falcon 9 rocket made its way up and away from Florida's Space Coast, and capping things off with one final one from John Pisani. And now I'll go ahead and do it for us for now with our live launch coverage of this Falcon 9 flight now in the books. But if you haven't already, be sure to subscribe to Spaceflight Now, turn on notifications, because we'll be back with you in the midnight hour as SpaceX prepares for its 500th Falcon 9 launch to date. Apropos is a Starlink mission heading off from its workhorse pad of Space Launch Complex 40. We'll be back with you with live coverage an hour before liftoff, which is currently planned for 1:29 a.m. Eastern, 05:29 UTC for those joining around the world. Want to thank our friends Pete Karstens with Max Q Productions, as well as Chuck and Jen Briggs for C&J Images for their assistance with tracking the Falcon 9 rocket. Thanks to our photography team of John and Michael out here, Adam had this one off, but I'll be back in action before you know it. Thanks to our Spaceflight Now editor, Stephen Young, who is running the technical operations of the broadcast. Thanks to Rick Donner, Jeff Hansen for holding it down in the live chat. Most of all, thanks to you for wherever you've been watching from. We certainly appreciate you being with us here at Spaceflight Now for live coverage, and we look forward to welcoming you back very, very soon. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Remember, be good to yourselves, be good to others, and we will see you next time, folks. And until then, bye-bye.